Hi everyone, it's Miss McCarter here. We're going to dive in a little bit more and look at some irrational numbers that we learned about recently. They're hard to understand if you're just looking at them. For example, the square root of 7. We see that, but what does that mean? So today we're going to learn a strategy that is going to give us a better approximation of what the square root of 7 actually means. First, we're going to go over some common irrational numbers. So you're going to see pi. You've probably seen it before. That one is hard to give an approximation. That's when you just have to honestly memorize that one. So if I pull up my nifty calculator here, I can type in pi. My calculator has the pi button. Yours should too. So if you click pi, what does it equal? 3.141592654, and then it goes on forever and ever, right? That's why pi is considered an irrational number. Well, we can abbreviate and we can just call it 3.14. That's one you're not going to be able to just figure out. You'll have to just remember that one. So pi is 3.14. Okay, so just keep that in the back of your mind, just a little bit bigger than 3. All right, now the square root of 2. What does that number really represent? So the way we can figure that out is there's a couple different ways. First, we could just plug it into the calculator. Square root of 2, what does that give us? Oh, that number that keeps on going forever and ever, right? 1.4. So I know that square root of 2 is somewhere in between 1 and 2. I'm going to teach you guys a way that we can figure that out without even using our calculator. So the square root. Let's think about what a number squared means. So the number, if any number squared means that number times itself, correct? So square root is working backwards. I know, so I have to think about my multiplication facts that I know. I can multiply the numbers times itself and I want to get close to the number that's in the square root. So for square root of 2, it's a small number, so I'm going to start small. I know that 1 times 1 equals 1. What that means is the square root of 1 is also 1. I know that sounds a little bit confusing, but since the square root of 2 has to be bigger than the square root of 1 because 2 is bigger than 1, that means that the square root of 2 has to be bigger than 1. Okay, that's great, but what is it going to be less than? I need an approximation. So let's go up to one more multiplication fact. What's 2 times 2? I know 2 times 2 is 4, so that in turn means the square root of 4 equals 2. Okay, square root of 4, I know right here has to be bigger than the square root of 2 because 4 is bigger than 2. So that means that the square root of 2 has to be less than 2. So square root of 2 has to be somewhere in between 1 and 2. And is that what our calculator told us? It sure did. 1.4. That is in between 1 and 2. Awesome. Let's try the next one without a calculator first, and then we'll go back and check. All right, so I already knew that 2 times 2 equaled 4. That's less than 7, so let's start there. Oops, sorry about that. Switch back to black. 2 times 2, like we said, does equal 4, which means square root of 4 equals 2. Okay, awesome. I know that that 4, lost my mouse here. I know that 4 is smaller than 7, so the square root of 4 is smaller than the square root of 7, which means the square root of 7 has to be bigger than the number 2. Okay, let's see what it's in between though. All right, I'll move up one more. 3 times 3, what does that equal? 9. Okay, I know 9 is bigger than 7, so I know square root of 9 equals 3. So like I was just saying, I know that 9 is bigger than 7, so I know that that number, square root of 7, has to be less than 3. So what is square root of 7 in between? The numbers 2 and 3. That's what I figured out. Let's go back and check using our calculator. So square root of 7 is 2.6. Perfect. It is indeed in between 2 and 3. Awesome. Last one for these examples here. Square root of 23. I did a bigger number, so we can just keep on going. So I know 3 times 3 equals 9, but 9 is not super close to 23, so I'm going to go bigger. So I'll go up one more. So 4 times 4. What does that equal? 16, which means square root of 16 is just 4. I know 16 is less than 23, so I know the square root of 23 has to be more or greater than the number 4. Well, let's see what it's in between though. So I'll move up one more. 5 times 5 equals 25, which means square root of 25, equals 5. Okay, I know 25 is bigger than 23, so that means the square root of 23 has to be less than 5. So what are the two numbers that the square root of 23 is in between? 4 and 5. Okay, let's go check our calculator. Square root of 23. Sure is. That is in between 4 and 5, 4.79. Awesome. All right, now that we have an idea of how to make some approximations with our irrational numbers, let's do some comparisons and see if we can figure out which irrational number is greater. So whenever I see two irrational numbers and I need to compare them, I want to put them in nicer terms that are easier for me to understand. So looking at pi, we have to remember, what did pi stand for? How much was it? I can double check in my calculator, but I remember that pi is 3.14. So I'm going to write that below. All right, now we have square root of 5. Again, I want that to be a number that's easier for me to understand and work with. So let's figure out what the square root of 5 is going to be in between. So I know 1 times 1 is 1, but that's still pretty low. That's not super close to 5. Let's see if we can get closer. Oh, I know 2 times 2 is 4, which means the square root of 4 is 2. Okay, square root of 4 is less than 5, so I know that square root of 5 has to be more than 2. Okay, let's keep going then. 3 times 3 equals 9. Square root of 9 equals 3. Awesome. I know that the square root of 5 is less than the square root of 9, so then I know the square root of 5 has to be less than 3. So I know it's square root of 5 is going to be somewhere in between 2 and 3. So if I'm looking at that, which one's bigger? 3.14 or somewhere in between 2 to 3? Well, I know 3.14 is bigger than 3, so I know pi has to be greater. So here we see pi is greater than the square root of 5. I can pull up my calculator to double check that. Square root of 5 is 2.23. That is indeed less than 3.14. So we did that correct. Let's move on. We just have 2 more examples here to go through. Okay, so I see this first one is still an irrational number, right? Those 3 dots mean that decimal is going to go on and on forever. So for that, we can just leave that one. I know that it's less than 1, right? It's close to the number 0 since there's no whole number in front of it. Okay, but what I don't know for sure is the square root of 2. So I know 1 times 1 equals 1. Like we went over before, which we know square root of 1 is 1. And then we double checked what's 2 times 2. It is 4. So I know square root of 4 equals 2. So I can see that square root of 2 is going to be in between the numbers 1 and 2. So which one is bigger? 0.36 and so on, or the numbers somewhere between 1 and 2? Well, obviously, I know 1 whole is bigger than a decimal of 0.3, so I know that the square root of 2 is bigger than our decimal right over here, our irrational number. Awesome, and last example we'll go over today, and then you'll get a chance to practice some on your own. So we have the square root of 12. Again, let's make that a little bit prettier for us. So I know, let's think of our multiplication facts that'll get us close to 12. Well, 2 times 2 is 4. That's not super close. Ooh, what about 3 times 3? That's closer. 3 times 3 is 9. So I know the square root of 9 is 3. So I know square root of 12 has to be a little bit bigger than the number 3, right? Let's see. Let's go up one more then. 4 times 4 is 16, which means square root of 16 is 4. Oh, perfect. I think I found what my square root is in between. Square root of 12 looks like it's in between 3 and 4. Okay, and then we have a fraction over here. 12 over 3, or 12 thirds. Oh, I actually recognize that's a rational number. I know 12 divided by 3 is just 4. So I can represent 12 thirds as 4. So I have 4 as a whole number, and then I'm seeing which one is greater, 4 or somewhere in between 3 and 4. Well, if square root of 12 is in between 3 and 4, then I know it has to at least be less than 4. So I know that 12 over 3 is greater than the square root of 12. Okay, hopefully that was helpful for you guys. Like I said, we'll have some practice for you to work on finding a good approximation for irrational numbers and being able to compare and identify which one is greater. Have a great rest of your day. Bye.